Hey everybody, this is Larry. This is me going Q3 of the weekly contest for 37 minimum time for K connected components. Hit the like button, the subscribe button, join me in Discord, let me know what you think about this one. Honestly, I didn't think this one was so bad, I want to say. I ended up taking 20 minutes on this problem, which is my longest problem of the day. Probably could have done it in 10 if I was more confident about it. And the short story is that I saw the binary search solution right away, and this is a binary search problem. We'll go over the complexity really. Yeah, I saw the binary search solution right away, but for some reason I thought it may be too slow, and I thought that maybe there's a O of n solution. Binary search, of course, is a little bit more expensive than that. Anyway, yeah, and this is a good practice in binary search for the answer, meaning that, okay, given this is the answer, is there a way to satisfy this condition? And if the answer is true, then now you take the half that you care about. In this case, this is going to be making it smaller, which is why we have to write. I'm not going over binary search today. Hopefully this makes sense. This is a binary search for the answer. Definitely just work on components. I don't think there's anything tricky about this binary search anyway. This is just that, yeah, if the middle is good, that means that this is inclusive. The way that I always set it up is just having inclusive bound, and then now I try to smaller half, right? So because I want to minimize, so we want the smaller half, and yeah, and that's the binary search. The top here, it is connected component, connected components, but also via destroying union set. This is probably the cleanest way to do it. You could still, I think you could still do it with DFS or BFS, honestly. By taking a subset of the edges and then just running the algorithm. But I think for me, I don't know, it's more natural to me. And here I reset the union find structure, and then yeah, for every edge that comes after, because basically for target time, what we're checking for is whether target time, if we are at target time and we removed all the edges before or on time, then how many components do we have left, right? Something like that, or whether we have enough components in this case. And yeah, and basically the way that I did is just I filled out the edges. I will continue though, because I sorted this, you could actually break, but or maybe break the other way, I think. Or maybe you're supposed to sort and then break that way. I don't know. Oh, that's why, because I will break, but then it doesn't check for the components. I don't know. But yeah, but this is going to be good enough anyway. You just filter those out, because if the time is after target, then you remove those edges, and you remove those edges by not adding, which is what this thing here does. And when you add an edge, if they're not already connected, you connect them. That means that you have one field component. If we have too few components, then well, that means that we have too many edges, so we have to wait later to remove more edges, and that's it. Yeah, so what's the complexity here? Well, this is going to be linear time, right? Because the union find data structure, it's going to be O of 1, and then here it's just O of y, where y is the number of edges. Like I said, I actually sorted this to make it y log y, and then maybe you could terminate earlier. I don't know, but it doesn't matter either way, because it gets dominated by this thing. Because this here, it does, let's just say O of 30 loops, which is actually technically O of log d loop, with where d is equal to 10 to the 9, which is the range of the number, right? And yeah, and then this one is going to be linear, right? And that's it, right? Or of y, if you want to be more precise. And you have y log d, which is fast enough apparently. I was worried a little bit. That's why I was trying to figure out doing a sort of a greedy. I'm not convinced that there isn't a greedy, but I don't know. I was just taking way too long. Yeah, and that's it. That's all I have with this one. Let me know what you think. And yeah, you could watch me sub it live in the contest now. I didn't realize you can do it more than once, but okay, fine. Q3. How am I doing on time? Took about 13 minutes, something like that. Okay, they haven't fixed it yet. Okay. Minimum time for K connected components. All right. Initially, the graph. Okay, so let me reread this. Can be removed at time x. I mean, remove is just the opposite of adding, right? So, I mean, first of all, we want the minimum time. So at the end, I'm just trying to think about this. I mean, I think this is pretty straightforward, but here's the concepts. Let's just write out. It's kind of weird that we have two union find problems in a row, though. I guess I should just copy from the other one. This is so easy to write, isn't it? Okay, so let's say, so how many edges do we have? And then edges are not related. That's a little bit awkward, but okay. Okay, it's not a binary search, it's just keeping track, but it is definitely very weird. Okay, so then yeah, I don't get it. It's just adding, right? Use up 2, and that's it. I want to know whether, like, is this a tree at the end, or can there be cycles? I gotta use the restroom real quick though. Give me a second. Yeah. Alright. I mean, this is just union find, right? But it can be okay. So you have to remove a minimum time. So in the beginning, we have a lot of components. So it's removal. I don't think this is that hard, but I'm just like, struggling to kind of make sure that I have the idea. Okay, so then now after the I mean, removal is just the opposite, right? So then There's something like this. So then now okay, components is equal to n then, right? And then now for if we remove at 3, then I guess, yeah, okay. So then now for UV, T and edges, right? And say if you find, or if, yeah, if you find of u is not equal to you find of v, then we union them. And then we components subtract by 1. If components is greater than equal to k, then best is equal to t. And then that's it, right? Can there be a -1? The answer is 0. Why is it 0? Am I understanding this right? I mean, I guess I can just run it. Technically, I think I want to return early, but of course then it's not going to get any bigger, but maybe I'm more on this one. Best is actually, I guess, just like the last number, which is fine. This is just not right at all. Am I misunderstanding this? Okay, so here you do. No, I'm adding this in a weird order. No, this doesn't feel right. Because you're adding them. But when you're removing them, right? So you add. How do you remove? Remove is not the same as reversing them, I guess. Okay, so let's say we do add order things, right? Maybe it is binary search. I don't know. Binary search would definitely do it, but I just thought maybe it'll be too slow. Let's binary search. I honestly don't know if it's gonna be fast enough, but that's why I'm a little bit worried about it. But yeah. I guess we can actually. It's not an edges, it's E. I think that's where I messed up a little. Oh, maybe it is actually. Lambda x. Basically, we want to go with connect. How many components are there, right? So t is greater than target, then we break. If components is less than k, then we return false. I want to say. I guess this is just return true. But okay, then now we say. It could be a little tighter down, but if this is good, then we want to try a later time. Key is okay, still not right. Okay, so if it's infinite time, then we pass all the. Maybe this is actually wrong. Because basically, if this is time, then we remove all the things under it. No, this is right. Maybe. Why is 2? Huh. So my time is equal to 1. Okay, so we have 2. A time is equal to 2. We do none of this. This component is equal to n is not right, is it? I think I got the direction wrong because that's when you remove. So it's this equal to maybe. Because that means the time that are smaller, you have to use it. No, that's not right. I mean, maybe it's right, but if it's smaller, we have to use it. So then if it's greater, then we will remove all of them. Okay, so I think that's right. Maybe this is not mine. Why? Let's do this for a second. If time is greater than target, we skip. Now we want to do it when time is greater than target, right? If the time of this edge greater than target, then we actually, oh no, then we skip it because we can remove it. Okay, so we want to remove all edges, so then we add to this. Yeah, okay, this feels more right though. Maybe not enough. At time 2, we remove these two edges and then now we have 3 components. So where's 4 coming from? Am I misreading this problem? Oh, at edge 4, because you remove that time. Oh, okay. No. Okay, so I think I got this one wrong. So you want to remove all the time be after that. Okay. So you want to remove all the nodes. This is right. And then all the edges afterwards you keep, and then you just count the number of components, right? This is right, so why is it wrong? All right, let's just take this out, and then now we can do target components. Okay. Oh, sure. Okay. At infinite time, there are 2 components. Yes, that's fair. Maybe it seems like this loop. Okay, so if this is good, then we want to try a smaller time. Silly mistake. I said the wrong thing earlier, so I just got confused. Alright, well, that's not quite right either. So at 0 time, we don't remove. So we have 2 components, right? And that's no. At 0 time, we don't. This is wrong again. Because we have to. No. If it's smaller than target, then we keep, right? So that means that this never happens. So then that means that we do this, right? Am I doing this right? Did I mess up parents? I mean, this is 2 components, but this is 1 component, right? So then why is this not here? Okay, so it is here, but then the components. Oh no, I'm looking at the wrong column. Okay, 1 is component. So if it's too small, then it is force, right? Oh, that's because I'm just, yeah. Where's my answer? I can't even tell in this UI. 3, 4, 0. Okay, so I guess I fixed it, whatever I did. I just had this here though, didn't I? Maybe I need it here and outside. I think I was just. No, then now it is 0. Oh no, maybe I was just looking at things confusingly. All right, I don't know if it's fast enough. I think that was the thing that I was worried about. Okay, maybe I shouldn't have. Like, that's why I was trying to do something funky, but I thought it was too slow. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.